All right, so we're going to go over all the key parts of Unit 4. I'm going to give you fairly explicit detail on how I'm going to ask about each of those topics, okay? Tell you about the test that you'll write on Monday, and then after I've done all of that, I will post the review sheet, okay, for this unit, and you guys can work on that if there are questions, specific questions that you have. Okay. All right, so first thing we went over in this unit was climate, okay? And the things that you have to remember about climate are, first off, the 4 components of climate, okay? Those 4 components are temperature, precipitation, light, and wind, okay? The reason you need to know those 4 things is because you will need to describe them as you think they exist for a given location. Okay. Along with that, you will also need to know the factors that affect climate, because obviously we did an activity on that. Okay, so factors: latitude, altitude, mountain barriers, proximities to oceans, centers of high and low pressure, okay, all those things that we talked about. And we talked about in this class as well how those factors affect certain parts of the country. Okay, or which ones are most important for certain parts of the country. So here's how I'm going to ask about this on the test. There's going to be a map of Canada on the test. One city will be selected. What you will need to do is describe the climate of that city as you think it is, and it'll be one that would be pretty obvious, okay? And then tell me why the climate is the way it is, based on what factors you think affect its climate most. Okay? So, if that city was Okotoks, spoiler alert, it's not Okotoks, okay? If it was, then you would describe something along these lines. Okay? In your description, include all 4 components of climate. So we would say, in Okotoks, light varies throughout the year, not only in duration, but also in intensity, meaning there's definite summer and winter. Okay? So in the summer, which is pretty much coming up here, okay, we get very direct, long duration sunlight. We get long days with directly overhead sunshine. Okay, that means a lot of heat gets put in, but in the winter the situation is exactly the opposite. This is because of our latitude. We are very far from the equator, and as a result, okay, the Earth's angle changes the sunlight we receive. All right, so I talked about a component. I talked about the factor that affects it. Okay? Temperature. Temperature is affected by the same factors that affect light, because temperature is related to the amount of heat that is received. Okay? You could also mention that we're at a high altitude, and that can also affect our temperature. So I've now named another factor and talked about another component of climate. Precipitation in Okotoks is highest in the summertime. Okay? That is due to the presence of mountain barriers, which blocks a lot of moisture from coming over during other parts of the year. All right, I've now mentioned 3 factors that affect climate, 3 of the components of climate. All right, wind. Winds in Okotoks are primarily out of the southwest, and that is again due to Okotoks' latitude. Done. All right, everyone kind of follow what I'd be looking for there? Talk about the 4 components, talk about factors that affect them, and that's what I'm looking for. Okay? All right, questions there? Climatograms. We talked about this day before yesterday. You are going to be asked to match a climatogram with a biome and explain. Okay, that's a very rough drawing of a climatogram, but if I give you a climatogram that looks like that, with a temperature line that's pretty much straight across, and precipitation bars that are quite high and also fairly uniform, which biome would we be looking at?
I forgot the name, like that's like near the equator.
Okay, it would definitely be near the equator because the temperature line would tell us that, and that would be part of your explanation. Okay, because the temperature does not fluctuate, that means the amount of energy received by this place isn't variable, so it must be near the equator. Okay, and we got high precipitation. This is the tropical rainforest. Right, so what we'd be looking for here is this biome represents the tropical rainforest because what we said about the temperature, okay, also describing the precipitation and its pattern. So I'm looking for you to be able to tell me, I can read the climatogram, okay, that's the temperature doesn't change, the precipitation is uniform and very high, okay, so that'd be like 2 marks. Okay, it's a tropical rainforest, 3 marks, and then explain why those things fit with tropical rainforest. Okay, talk about it being near the equator, okay, that kind of stuff. That's what I'm looking for with that one. Okay, energy transfers in global systems. So this was lesson 3 where we talked about conduction, convection, radiation, where we talked about the 3, so those were the 3 methods of heat transfer. Then we talked about the other 3, which are the 3 things that can happen to light when they strike the Earth's surface. They could be, A is absorbed, what else? This thing determines it. Reflected, or plants do it. Photosynthesis, converted, okay, converted. Absorbed, reflected, converted. Okay, how much is absorbed, how much is reflected? Determined by albedo. Okay, important term, important we know what it means. Okay, this tells us the reflectivity of the Earth's surface. The higher it is, the more reflective the Earth's surface is in that location. Snow has an incredibly high albedo. Bare black dirt has an incredibly low albedo. All right, so those are the 3 fates, okay, of light. Here's what I'm going to ask that. Written response question. Okay, same as the other ones I've talked about.
Is that why, like, when you're like skiing or snowboarding, the snow reflects it so you can get like sunburned?
Yes. Yeah, and snow blind and yeah, exactly. You're also at a high altitude, so there's less protection from the UV. But yeah, definitely reflects back at you. All right, so here's how I'm going to ask this. Satellite picture of a place on Earth, probably somewhere nearby. Okay, I'm going to want you to look at that picture. It's in color. Okay, and based on what you see in that picture, tell me what's going to happen. How much is absorbed? How much is reflected? How much is going to be converted based on what you see in that picture? Okay, talk about this as well. Right, that's what I'm looking for in that picture, for you to be able to look at an area and determine how much energy transfer, absorption, okay, conversion is going on there. That's what I'm looking for. All right, on those same lines, or within that same lesson, another written response item is going to ask you about transfers of energy on a global scale. All right. So obviously the atmosphere has a big role to play in that. Within the atmosphere, because it's fluid, energy will be transferred by convection, which is wind. Okay, the jet stream will move latent heat. Okay, remember that latent heat is an important energy transfer mechanism. Okay, within the hydrosphere we have convection. Okay, not as important. Okay, within the lithosphere it's all conduction. Again, not important. Mostly you're going to talk about the atmosphere and the role it plays in transferring energy from place to place. Talk about wind. Talk about jet stream. Talk about latent heat. Okay, that kind of stuff. Okay. Another question I'm going to have on there is going to have to do with the three methods of heat transfer: conduction, convection, radiation. Albedo will probably get worked in there. Okay. So I'm going to have a picture of a device or structure or something like that. Okay. And I'm going to ask you, in this situation, how does this structure work in terms of heat transfer? We did an example of this in class when we talked about how a cooler works. Okay? How the insulation inside the cooler prevents convection and conduction because there's all that trapped air that can't move. Conduction can't occur through air. Convection can't occur because the trapped air is trapped and can't make a convection current. It's white on the inside, so all the radiant energy gets reflected, all that kind of stuff. Okay? So you're going to have a picture of a device or a structure, and you're going to be asked, based on your knowledge of heat transfer, okay, and you're going to want to write these three words: conduction, convection, radiation, okay, explain how it works. Right? Be a 5-mark question. What I'm looking for is those three methods of heat transfer identified and how they're working or being thwarted, okay, by that particular device or structure. Okay, so this here was my drawing of insulation. Okay, I drew something similar to that before, okay, because I can't draw. Okay, so that's all the little dots. That's the trapped air, right? The air is trapped between the fiberglass fibers. Okay, so it can't move. You can't get convection. Okay, there's no heat going to be transferred. So on that note, what part of your house is most responsible for your house losing energy in the wintertime? You could have a little bit of heat loss through the basement, but remember the basement's also the coldest part of your house, because all the cold air obviously goes down, right? But you could have some conduction loss. That's why the basement floor, if you don't have in-floor heating, is cold, right? It conducts down through because it's made of concrete, it's not insulated. I was thinking of another thing, okay, a place where heat might get out. Doors, windows. Okay, your doors and your windows are the two places where energy gets lost. Okay, reason for that? You've got walls that are 6 inches thick and they're filled with insulation. Your door is 2 inches thick. It can be, they're still insulated, there's insulation inside there, but obviously that's significantly less insulation than it is in the rest of the walls. Okay, windows. Even if you have low E windows, all right, that would be like triple paned glass. Okay, if you have triple paned or even double paned windows, there's air spaces are actually vacuum or filled with a noble gas, okay, in between the panes of glass. That prevents convection from happening because the air is trapped and it can't move. If you have triple pane, you've got one extra layer. Most windows are double pane. Okay? And so you got that extra layer of protection against convection. But your windows are by nature transparent, which does not prevent which method of heat transfer? Radiation, yeah. Okay. If somebody goes outside of your house with one of those forward-looking infrared cameras, okay, and points it at your house, your windows will glow because energy is radiating out the windows because they're the least insulated part against that. The rest of your house, the walls, are going to prevent radiation because they're opaque. Radiation doesn't get through them. Okay, but through your windows, very easy. Okay, does that sort of make sense? Right. Why a greenhouse is not a great place to stay in a cold weather. Okay, because it's clear, not insulated, it's just glass. All right, wind patterns. So there'll be a question on wind patterns as well. Okay, there'll be a picture, better than the one I drew here. There'll be a picture like that. And it'll have the arrows and stuff on it. I want you to explain how we get these patterns of prevailing winds, okay, on Earth. And we talked about that in lesson 4 on global wind patterns. Okay, so remember that wind patterns, or patterns of prevailing wind, are the result of those two things occurring at the same time. Right? So hot air is rising, cool air is descending, but while that convection current is going on, the Earth is rotating underneath it. Okay, that's the demonstration I kind of showed you with the volleyball. Okay, that was the Coriolis effect, that deflecting of the winds. It's that combined with the movement of air in another direction that causes prevailing winds. Near the equator, you've got the trade winds, which are those easterlies. Here we have the westerlies, and north of us, they have the polar easterlies. Okay, that's all because of latitude and convection and the fact that the Earth spins under its atmosphere. Okay, just be able to explain that. Okay. All right, and sorry, the Coriolis effect, there's going to be a separate question on the Coriolis effect. Just need to explain kind of what I was just talking about, okay, which is as something spins, okay, the object will be deflected because it's trying to move in a straight line while something is moving underneath it. Then we talked about specific heat capacity. Okay? You'll need to know what it is. There's a couple of multiple choice questions about what specific heat capacity is. Okay? It's basically a measure of how quickly something can change temperature. And there will be one written response problem on just specific heat capacity, like the ones we did in class. So somebody heats up an iron rod with 200 joules of energy. The rod's mass is 2 kilograms. How much will the temperature change by? Okay, so you'd be using E equals mc delta T, okay, and solving for temperature change. Okay. Maybe I tell you how much this temperature changes and ask you to calculate the mass of the iron rod or something along those lines. Okay. The other reason we need to know about specific heat capacity is it does have a role to play in this. Okay. Why proximity to oceans is a factor that affects climate. So if in that previous question I was telling you about with the map, if the city is near the ocean, that's something you could probably work into your answer. Okay. Water has a very high specific heat capacity, thus it holds energy, and that can regulate the climate of any city that is on the ocean. Okay, and then latent heat. Obviously we need to know what latent heat is because it's part of energy transfers on Earth. It's also going to have the heating curve problem I was telling you about. And we worked on those a few days ago, and being able to draw the heating curve of water and then solve a problem and how much energy is required to change 2 kilograms of ice at minus 15 into water at 50 degrees or something like that, okay? All right, so those will look like that. Okay, so remember that on the heating curve, we use different formulas for different parts. Okay. Anytime temperature is changing, the kinetic thermal energy is changing, and we use E equals mc delta T because temperature measures kinetic thermal energy. Okay. Anytime the line is flat, we're changing the thermal potential energy. If we're melting and freezing, we use E equals mLF. Okay. If we're vaporizing, we use E equals mLV. Right? All of these numbers will be on the test. Okay, so there'll be all the heat capacities you'll need will be on there. Okay, LF and LV will be on there. Okay, so you'll have everything you need. Right, questions on that? Okay, so there will be, and I told you that the other day, there will be a latent heating curve problem. Last thing we talked about, biomes. Okay, very simply, you've got that climatogram question on the written response, obviously, but there are a number of multiple choice questions where you will be shown a picture and given a description of a biome and asked to identify it. Okay, remember to use both. Don't just look at the picture. Okay, make sure sure you read the description. For one of them, it's really important, okay? Two of them you could probably just identify from the picture, but one of them, you definitely need to read the description as well. Okay, on your unit exam, there are 25 multiple choice questions. Okay, the multiple choice questions cover basically just the recall type of stuff. Like they talk about the parts of the Earth: atmosphere, lithosphere, hydrosphere. They talk about like the layers of the soil, so A horizon, B horizon, C horizon. They talk about the biomes, okay, obviously those ones we were talking about with the pictures and descriptions. There's also a couple that have to do with the water cycle. Remember that we looked at the water cycle mostly from a perspective of energy, okay? But you still need to know the parts of it, so runoff and evaporation, transpiration, precipitation, infiltration. Okay, make sure you look over that in your notes. There's a few things on factors affecting climate. There's a couple of questions that are application questions. They're still multiple choice, but they're application on heat transfer. Okay, convection, radiation, conduction, and they're going to make you think a little bit. And there's a couple of latent heat things, just asking about latent heat, not asking you to make any calculations, but just asking about latent heat. A couple about albedo, okay. More stuff on heat transfer. That's what's in the multiple choice. Right. For the written, there are 9 written response questions. Okay. So for the written response questions, the first one is the climatogram. For the climatogram, make sure you look at the shape and the numbers carefully. Okay, like actually look at the graph. Don't just look at the graph's shape and go, oh, it's this one. Look at the numbers on the graph, okay? Both precipitation and temperature. Okay? Because scale can sometimes be misleading, right? The scale on this particular one is very, very small. So all of the changes that occur look really, really big, okay? They're not as big as they look just at a glance. If you look at the numbers, you'll go, oh, that actually isn't very much, okay? Now, to give you an idea, a lot of precipitation would be several hundred millimeters of rain in a month, okay? Very little precipitation would be less than, let's say, 90, okay? For us, our wettest month, June, is usually somewhere between 70 and 90 millimeters of rain, okay? And that's our wettest month. This is a fairly dry place, okay? Everybody with me there? Okay, second question is the map question, okay, with the city. Okay, third question is the global energy transfers question, right? That's the one where you're talking about, latent heat and jet stream and all of that kind of stuff. Okay, talk about energy transfers, convection, all of that on a global scale. And question 4 is the prevailing winds question. patterns question. Okay, question number 5 is the satellite picture question. Number 6 is the device/structure question, where we're talking about heat transfer, convection, conduction, radiation. Question 7 is the heat capacity problem. Question 8 is the latent heat problem, so the heating curve question. And number 9 is a question that's going to make you think. Okay, it's a little bit of everything. I'm going to ask you to apply a lot of what you have learned in this unit to one situation. Okay. So you have to integrate things like heat transfer, water cycle, latent heats, factors that affect climate. It all kind of comes together into one. Okay. This is one of those. I can really show you what I learned in this unit and apply it in this particular, as opposed to I memorized a whole bunch of stuff and I can write it down. Okay, that won't necessarily get it done on that question. Okay, that is it for that test. All right. Questions from you guys? Anything you want me to go over in more detail, demonstrate, re-explain?
Will all this stuff also be on the final in this section?
Yes, I will test all of these things on the final, but not all of them as written response questions.
Okay.
There's a lot more multiple choice for this unit. The big things on the final from this unit would be a climatogram, a latent heat problem, and probably something about heat transfer and prevailing winds. Okay, then what I will do right now, guys, is I will post the review package on Google Classroom so that you have that. This first thing here in the stream, Unit 4 exam review. If you click on that, okay, it'll take you to this, which is a bunch of activities and questions that you can try to prepare for the unit exam. Okay, there's even a latent heat problem. The answers for both the specific heat and latent heat problems are in there. Okay, the other stuff is more about explanation. I left the location on this climatogram here, right? So that, you know, if you were looking at it and deciding where you think it was, you could then look at the city's location and figure it out from there and know if you did it right. Okay, so that's why the city is actually still on there. Right? Obviously, on your unit exam, the city will not be on there. All right, if more questions come up, please ask.